Welcome to Unit 10, Part B, Descriptions of an AC waveform. In Part A, you have learned that AC voltage and AC current are both sinusoidal waveforms. Without loss of generality, we will focus on sinusoidal voltages in this part to learn more about AC waveform. A sinusoidal waveform has its magnitude that varies as a sine function, so it can be represented by a sine function equation. If a power socket is connected to a voltmeter and the readings of the voltmeter are plotted out, you will see an alternating sinusoidal waveform. AC waveforms are sinusoidal waveforms. There are a few important parameters which shows how one sinusoidal waveform is different from another sinusoidal waveform. The first parameter is the peak value, labeled as V peak. It is equal to the maximum voltage of the sinusoidal waveform. The variation of peak value is the peak-to-peak value. It is the difference between the maximum voltage and the minimum voltage. The second parameter is period, represented by a capital letter T. Period is the time duration to complete one cycle. Sinusoidal waveform is a periodic waveform. It repeats itself cycle after cycle, cycle after cycle. A cycle can start from any point on a periodic waveform, and the cycle ends when the waveform reaches back the same level. For example, from zero level, reaching back the next zero level is a cycle. From zero level, reaching back the next zero level is another cycle. Or from the bottom level, reaching back the next bottom level is a cycle. Or from one peak level, reaching back the next peak level is another cycle. No matter where your cycle starts, the duration of one cycle is a constant, which is called period. The third parameter describing a sinusoidal waveform is the phase. That will be discussed later on. As mentioned, period is the time duration to complete one cycle. Period is labeled by the capital letter T. It is measured in units of seconds. The frequency of a periodic waveform is equal to the number of cycles in the waveform in 1 second. Frequency is represented by the letter F. It is measured in units of Hz, Hz. Do take note that use capital letter H and small letter z. Frequency is equal to 1 over period. It is because 1 second divided by the period is equal to the number of cycles in 1 second. In this example, you're required to determine the period and the frequency of this sinusoidal waveform. From 0 to 20 milliseconds, the waveform completes one cycle. Therefore, the period is 20 milliseconds. Frequency is equal to 1 over period, that is 1 over 20 milliseconds, which can work out to be 50 Hz. This sine wave can be represented by this sine wave equation. 2 pi ft, f is frequency measured in Hz, t is time measured in second. Since frequency is equal to 1 over period, 2 pi ft can be written as 2 pi t divided by the period. V bracket t doesn't mean V times t. V bracket t means the voltage at a time instant. We'll discuss the details of this equation a few slides later. The peak value V peak of an alternating waveform is equal to the maximum voltage of the waveform. The peak-to-peak value V peak-to-peak of an alternating waveform is equal to the difference between the maximum voltage and the minimum voltage. Obviously, V peak-to-peak is equal to double of V peak. From here we can see the peak value of the sinusoidal waveform is 0.5 volt. So we can write down V peak is equal to 0.5 volt. Peak-to-peak value is equal to 2 times of the peak value, so it will be equal to 1 volt. Peak-to-peak value is also equal to 0.5 volt minus negative 0.5 volt equals to 1 volt also. In this example, you are required to write the sine wave equation for this sine wave. This is the general equation for a sine wave. You should remember it. V peak is the peak value. It can be checked from here, 0.5 volt. Frequency is not directly given in the figure, but frequency is equal to 1 over period. Period can be checked from here, 20 milliseconds. Why? Because from 0 to 20 milliseconds, the sine wave completes one cycle, so the period is 20 milliseconds. Substitute in and simplify this expression, we can find the sine wave equation to be Vt being equal to this expression.